So, how do you think your app will look on desktop windowing?
Amazing. I mean, can you see the UI? That's amazing.
Okay, so it may look good as a phone app until users go all the way to the other side.
That's beautiful. That's a big chart.
Yeah, then it doesn't really shine. You can see that in desktop windowing, even if you lock the orientation to portrait or any other orientation in your app, users can still freely resize it. At the end of this talk, hopefully, you will learn how to go from that to this one, which is using the space a little bit better. Hello, everyone. Welcome to our presentation, Android 15's Desktop Windowing, Developer's Guide to Building Desktop-Level App. Before we start, here is the link where you can ask all the questions during the talk, and then we'll try to answer them at the end, or we can catch up later.
Okay,
so,
probably let's wait a second that they get the joining code.
Yes.
So the code is DCITA24. Okay? Shall we start?
All good. Let's get right into it. So, if you're here today, maybe you already tried desktop windowing, maybe you're just curious about the feature, maybe you are already optimizing your app for that. So, quickly check, room check, raise your hand if you have already tried desktop windowing. That's good.
Yeah.
Okay. Then this presentation is for you because we're going to explain what it is and how you can make your app shine on that. What it is. So, desktop windowing is a new feature in Android 15 tablets, currently in developer preview, that allows users to run multiple apps simultaneously and freely resize the app windows. It offers a more flexible and desktop-like experience. It's not just freeform windowing. There is a new UI and a new set of API to enhance users' productivity on Android tablets. Here we can see the anatomy of the screen when desktop windowing is enabled. So things that you should notice. Of course, multiple apps at the same time, side by side. Only one app at a time is on focus. The taskbar is fixed, and it shows the running apps. Users can also pin their favorite apps for quick access. And you can see there is the new header bar, which is reported as a caption bar, with the window controls, the logo, and the name of the app. How to start desktop windowing? By default, every app will still open in full screen. There are a few ways to enter the desktop. First one is you can drag the window handle that you can see, and then from then on, once you are in the desktop, every new app will open as a freeform window. Users can also invoke desktop windowing from the menu that shows up below the window handle or with the keyboard shortcut. It's important to mention that desktop windowing is really meant for productivity, and it's really great to be used with the external peripherals like mouse and keyboards. If you close all the desktop windowing apps, it will go back to the full screen apps as usual. But let's get a sample app, see how it looks like on phones, on desktop windowing, see how we can make it better. This is our sample app. Fitness tracking, kindish.
It does everything.
Yes. So you can see it counts the step. You have this bottom navigation. This is the home screen. We have another screen that counts the calories, the food. From that button, it will open a new screen, which is the detail to add the food that you are consuming. And then even another one with the sleep data and the detail of the sleep data. This is random data, right?
Yes.
Because it's a pretty accurate representation of my lack of sleep since my daughter was born.
Yeah, that
Let's go.
sounds reasonable.
So, how do you think your app will look on desktop windowing?
Well, amazing. I mean, can you see the UI? That's amazing.
Okay, so it may look good as a phone app until users go all the way to the other side.
That's beautiful. That's a big chart.
Yeah, then it doesn't really shine. You can see that in desktop windowing, even if you lock the orientation to portrait or any other orientation in your app, users can still freely resize it. At the end of this talk, hopefully, you will learn how to go from that to this one, which is using the space in a little bit better way. One thing I want you to notice, the tablet has a bigger display than a phone, but actually your app can live in a way smaller window. The minimum window size and desktop windowing is 386 per 352 dp. So it's smaller than most phones. And the concept of resizability here goes from the super small window to the super big window. And that's why
Your app should be adaptive, but you knew that by now, right? Yes. Okay, so in order to get your app fully adaptive, there are 3 main steps that you need to take. Okay, first, as Franz already mentioned, you should remove the orientation lock and you should enable resizability. Okay, so locking your app in portrait, please no, and make it not resizable, please not again. Another very important step is retain your state. It doesn't matter how your state looks like, it should always be retained. We see that more in detail later, but you can always decide if you want to manage your state by overriding some configuration changes or basically not managing them at all, but your state should always be retained. And last but not least, your navigation should adapt to the amount of space that you have available for your app to run, because we saw that we might have a very, very tiny space, or we can get the full screen. We never know. Okay, so should we get started? Perfect, I love this energy. Okay, so how do you do it? I mean, it looks simple, and it's simpler than we can imagine. There are 5 things that we need to do. First, we remove the orientation lock, sorry. The orientation, we probably keep it, but the orientation lock, no. We save the state. How do we save the state? Well, the vast majority of times, using a view model will help you. Then, navigation. We switch from the bottom navigation on smaller displays, well, smaller surfaces, to the side navigation on bigger surfaces. That's much better for ergonomics, and that's much easier for your user to navigate on bigger screens. Then, we leverage well-known patterns for UI interaction like list details or supporting pane, so that we can have a better management of our space across the whole window. And then, we make it shine. We leverage particular features that are only available to certain certain sizes to really make a difference for our users. So, first, orientation restriction. How do we get rid of this? Well, we need to delete something from here. That's a normal declaration in our manifest for an activity. And you can see that we have here the resizable activity set to false and the screen orientation to portrait. Well, we need to get rid of those 2 lines. Also because Android Studio is pretty clear about it. So that's the first step. That was easy, right? Also, if you are calling set requested orientation, that count as well. So you should not call set to requested orientation. Okay, next, save the state. Because what happened so far, at least in our app, is that, of course, we were not retaining the state. So as soon as you remove the orientation lock, a new random value was generated, right? So how do we make sure that this doesn't happen anymore? Let's see how the repository is implemented for what concerns the step counter. So here you see that it actually gets the actual steps that you made during the day.
Yeah.
Okay, right, because we all do that. How do we make sure that this is actually not called every time the activity is recreated? Well, the easiest approach is wrapping this in a view model. Okay, why did I choose a view model? I chose a view model because view model was made to survive configuration changes. So basically we are saying our repository that we don't need it to give us a new value every time, we just need to give us a value when it changes. We listen to it as a state flow and then we can use it inside our composables. Okay, now navigation.
Nice.
Right? So, before we dive deep into navigation, I want to refresh a concept that I probably stressed a few times. Window size classes. Okay, so far we talked about how much space we have on screen. But how do I do that? Do I get the exact dimension of my window? Yeah, no, that doesn't scale well. It's going to be complicated. So we can leverage the window size classes. Window size classes are opinionated buckets for both width and height that define how much space our app have to run. So if it's less than 600 dps, for what concerns width, we think that that's a compact surface. And it goes all the way to 840 for a medium size, and then we have the expanded. So we have these three buckets, and we have them both for width and for height. But we usually only take into account width. Okay, why is this important? Because we want to make some changes only when we are on a compact surface. Okay, so this is how our app looks like. Of course, this doesn't really look like compact, right? So when we are here, we want that navigation that's on the bottom to be on the side. Luckily, well, no, first, before luckily, let's see how we calculate how much space we have. So first, we declare the value. Then, we invoke the current window adaptive info. This function, from a library that we're going to see in a second, will return us all the data related to the current window. In our case, also the window size class. The window size class is composed by a pair of width and height. So, as we just mentioned, what we're going to check is if our width is actually smaller or, well, is equal to compact or smaller than medium. Okay, so where does this function live? Well, not only this, but all, well, everything related to navigation can be found. Again, I forgot that we changed the order. Again, well, I'll adapt. I mean, we are talking about adaptive apps, so it makes sense. So, this is a normal scaffold, right? Are you all familiar with this structure? Raise your hand if you are. Yeah, me too, I don't really know, but again. So, let's make a quick show of hands. How many changes do you think that we need to make in order for these to automatically switch navigation? Let's say 10 or more lines affected. Raise your hand for 10 or more. 6 or more. Exactly 4. Less than 4? Yeah, you're way too optimistic here. Okay, so all of these is in the Material Tree Adaptive Navigation Suite. Okay, already available. So you can go on and try it today in both stable and alpha versions. Okay, so, well, you need exactly 4 lines. How do we change those lines? Well, first, you get rid of the bottom navigation, so you delete that. And then you transform your scaffold, your bottom bar, and your bottom navigation item to look like this. So your scaffold transforms into a navigation suite scaffold, your bottom navigation transforms into a navigation suite item, and here is what actually the nicest thing happened. Rather than using a specific composable like the bottom navigation item or the navigation rail item, you use item. Because behind the scenes, they don't change much. They are an icon, a label, they change when they are selected, and they have a behavior that is run when you click. So why not having a single function to represent them both? And this is why we only need to change 4 lines. Amazing, right? Yeah. Amazing, right?
Yes.
Great. When I ask a question, I expect a reaction, just saying. So, and now what we got is actually this. So, it looks much better already, but still we are not really leveraging the space that much. I mean, I love the big chart, but yeah, probably we can do something about it, right?
Can be better.
Yeah, it could be better. Slightly better, not much.
It can be better.
I mean, we are aiming for perfection here. Okay, so let's talk briefly about canonical layouts. You can think about canonical layouts more or less like design patterns for UI interactions. Okay, so they are well-known solutions for common problems. For instance, one canonical layout that I'm 100% sure that you are all familiar with is the list detail, which is a list of items, you click on one, and the details related to that specific items opens. For instance, a news app. You have a list of news, you tap on one, and you read the whole news. That's a list detail pattern. Okay. Are you all familiar with these patterns? Yes. Perfect. We're going to see another one then, because, I mean, the one was too easy. So we see the supporting pane. So before we dive deep into that, we need to prepare our code. So this is our navigation tree. It's fairly easy. Like we have a topmost navigation, we have a list of destination. When you tap on the food, you open the food detail. When you tap on the sleep, on the button in the page, you open the sleep detail. Fairly easy, right? Super easy. We pass in the nav controller so we can navigate back and forth, and that's done. Normal compose. But we can make it even easier. Do you believe me?
I actually do.
But because you know the talk. That's why you believe me. Maybe, I love the maybe. Okay, let's see how we can do that. So first, we need another library from the Material Tree Adaptive Suite. Also, this one is available, so you can go and try it as much as you want. So, first, what we want to do is grouping our main content with its detail. Okay, this is important that we group them because what we're going to use will provide the navigation between the two without our nav controller to actually need to do anything. So we will group the food and the food detail in the food page and the sleep detail in the sleep page. But how do we build them to make sure that they actually work exactly as we expect them? Because again, what is the interaction that we expect? Let's take, for example, we are on a phone. We want to show the detail on top of the main. But when we are on a bigger surface, what we want to do is showing them side by side. So we're going to wrap them inside a single composable. Okay, one for the food and one for the sleep, both the main and the detail. Now, once we group them, our navigation will look like this. So it's much easier because at this moment we only have the root navigation. Okay, only the elements that you declared in the navigation before, because the rest will be handled by the library. How that? Well, first, we need to declare a navigator and a coroutine scope. We need a coroutine scope because this specific navigator is asynchronous. So, well, it has a suspending function, so we need the coroutine scope. Now, we have our composables. What do we do with them? Well, first, we declare a supporting pane scaffold, and we pass in 2 values from the navigator. We're not gonna dive deeper into this because most of the times you're gonna just use the scaffold directive and the scaffold value. But what matters most to us is how we're gonna take the sleep and the sleep detail and place them in here. So first, we know that our main content was the sleep page. So what we do is placing them as the main parameter. And if you remember from earlier, we passed in the navigation. What we do here is specifying where exactly it should go. In this case, we are not defining a specific route. What we are specifying here is actually what role it should navigate to. We don't know what will be this role. We know it will be the support. So when we are here, we tap on the button, it goes to the supporting pane. Super easy. But how is gonna look like our support? Well, slightly more complicated, but not much. What we have here is exactly the same thing because we have our composable, and now our navigator will navigate back. Basically, when we want to close with our button that we already had in our UI, we invoke the navigate back. But there is another little piece that we need here, which is the back handler. This is super important because the back handler is what will come into play when you are on a compact display and decide to swipe back. As we can see, it is only enabled when we are on a compact screen or surface. I should not say screen.
Window.
Window, yeah. So, whenever we swipe back and we are on a compact window, then it will navigate back. Okay, but again, the amount of code that we needed to change in our composables is fairly limited to the navigation. The rest are a few lines that most of the times will not change much. Okay, but now we want to make it shine. So we decided that we want to go all down the full path, and we want also to have those 2 composables to expand based on the user interaction. So what we do is actually go and add 2 more parameters that will enable the pane expansion feature. So the important part from this is what goes into the pane expansion handle. As of today, it will only accept a pane expansion drag handle in which you can define your own color scheme and a few other parameters. And what you get here is this interaction. Automatically, we didn't change anything else. We just wrapped our composables inside the supporting pane scaffold and add those 2 parameters. And that's the effect that you get. It is much, much, much better, right? Thanks.
Yes, it is.
Thank you. But, I mean, I've been using desktops for a few years now. So when I started using computers, smartphones were not invented yet. I feel old now. So there is something that we are somehow forgetting here. And there are some features that desktop users expect. Like, for instance, drag and drop. Because, I mean, I'm used to drag and drop every day on my desktop computer. So how do we do that with Jetpack Compose? Well, let's take, for example, a very complicated composable behavior. So we have our text composable, and its content. Of course, you can add everything that you would normally add, but I mean, we don't have unlimited space. So for brevity, I only put that. And what we use is actually a single modifier. So don't be afraid of the syntax. This is the syntax that is currently available on the stable version of Compose. From the alpha, this is going to be simpler. It is simpler. If you want to try the alpha, I'll show you how to do it. So we use the drag-and-drop source modifier, and we declare a drag-and-drop transfer data. This is the most important part, because this is where you define what kind of data you're going to share with drag-and-drop. But if you want your app to be able to actually cross the boundary of the window when you are using drag-and-drop, well, you don't have to forget this flag, because this flag is what tells the system that your drag option can actually cross the boundaries of the window. So if you notice, I didn't talk much about the detect tap gesture and start transfer, because those two calls are not needed if you switch to the alpha of Jetpack Compose. You only need to remember about the drag and drop transfer data and the clip data implementation. Okay, super simple, right? I see less convinced now.
You should show them how it looks like.
Let's see. Does it work? I'm not sure. Let's see. So, this is how it looks like. And again, it was like 4 or 5 lines of code. Thank you, but that's actually not everything, because there is something else that we can use to leverage drag and drop, right?
Yeah, in desktop windowing, you can also start multiple instances of your app with drag and drop. So, are you familiar with multiple instances, right? So every time in Android you start a new task, it will open in a new window. On phones, sometimes maybe you don't notice this because the windows are stacked one on top of the other. But if you start an activity with a new task and then you navigate to the recents, you can see actually 2 instances of the same app. In desktop windowing, this is much more noticeable, and it's also very useful. Let's say you want to edit documents. Maybe your app edit documents or open different items. You can open them in different windows. You can have users reference one while editing the other. You can have drag and drop between them, sharing data. It's really what users on desktop are expecting. And multiple instance with the drag and drop was introduced with Android 15 SDK 35. I'll show you how. First of all, we need to enable multiple instances. So you need to define a launch mode that supports multiple instances. In this case, I'm using a single instance per task. That means every time I open the activity in a different task, it will open a new instance instead of bringing the current instance to the top of the stack. And then this is new SDK 35. This is a new property to tell the system launcher that your app is actually supporting multiple instances. So users may be able to start another instance directly from the launcher or the taskbar or other system UI components. Now let's see the drag and drop part with an excellent example, which is Google Chrome. Chrome on desktop windowing allows you to drag a tab out of the app window and it will open a new instance of the app. The code is very similar to the drag and drop we already saw. There are a few differences. In the clip data, you need to add the intent of the activity that you want to start. And in the drag and drop part, you need to use this new flag introduced with the SDK 35, intent sender on unhandled drag. That means if the drop ends on the wallpaper, not on any app, it will be consumed by the system that will start the activity that is specified in the clip data. Another thing that you may have noticed, I don't know if you had, how Chrome customized the caption bar, the header. Let's see how. Now you can notice it a little bit more. Basically, they are drawing directly into the header to use the space better and have this desktop-like experience. There are two new APIs for that. One allows you to make the insets transparent, so you can draw on top of that. And the other new API, the other API is meant to give you the rect where you can actually draw. So the part of the insets that is not used by the system where it's placing the logo, the name of the window controls. I was assuming we didn't have much time to see the code, so I'm adding here the link, Google Desktop Windowing, where there is the full guidance on how to achieve that. And looks like we're done. Few takeaways. First of all, you need to test how your app behaves on desktop windowing. You don't want surprises. You can try it on the Pixel tablet, on the Pixel tablet emulator. Just go into developer options and enable freeform windows. I also have my tablet here, so maybe you can even give it a try. Think adaptive. So resizing can happen every time. It happens, of course, in desktop windowing, but it happens when you unfold a foldable, when you go on the split screen. And you need to shift the whole logic to rely on the window sides instead of the display sides. And don't forget that the window can be very small or very large. Then, use the supporting libraries. Don't reinvent the wheel. We have these Jetpack libraries that will make your life much easier. And leverage the new platform features. Don't look at desktop windowing like, oh, this is another feature that you have to support. No, try instead to think, how can I make my users happier, more productive, using the new platform features? And hopefully, while you're doing this, try to have fun, as always. Thank you.
Yeah, massive round of applause for you two. Woo! Well done. Yeah, sorry, this is my attempt to do all things in one. How are you both feeling? If you just join me over here in the lighty area. Yeah. It's all lit, but there you go.
It is very lighty. It's good.
Good?
Nice.
Perfect.
You ready for some questions? You've done the easy bit now. No?
The hard one for Rob.
Okay, all right. Hard one for Roberto. Okay, perfect.
No, you should not. Don't trust me.
Right.